Yo, yo. Been traveling for a bit, but we're back. Um, so I wanted to, so there's been things that I've been thinking about in relation to Protoflow, and it's helpful to have someone that's actually familiar with this. But I had a friend suggest I go through this guy's category theory videos, and what's interesting about it is it's kind of where math and programming like intersect. I guess I don't really know. That's why I'm watching these videos, but they're very interesting. So I think I'm just gonna like kind of let this play, and then if something comes to mind, like I'll talk about it. But otherwise, I'm just gonna be coding. So that's that.
That's just a branch of mathematics that was created to deal with paradoxes. And then there is logic, and logic was created, long time ago by the ancient Greeks, right? They used logic. So there are laws of logic, and people have been studying logic for thousands of years, right? And at some point, people suddenly realized that all these distinct areas of mathematics are exactly the same. This is called the Curry-Howard-Lambeck isomorphism, which says that whatever you do in logic, right, can be directly translated into whatever you do in type theory. They have exactly, it's not like they are similar, they are exactly the same. There is a one-to-one correspondence.
Finally hung up.
And the Lambeck part of this isomorphism says
1,000 cranes that I folded.
Category theory, there are certain types of categories, the Cartesian complete categories that they actually totally describe the same thing. So it's like there are these three different theories. One is about computing, right? One is about categories, another is about types, and they are all the same. So like essentially all our human activity is described by one theory, okay? So this is like really mind-blowing. And of course, mathematicians, when they discover things like this, they turn philosophical, or I wouldn't say religious, but at least philosophical, right? It's like, oh my God, we are discovering stuff. It's like you're not really creating mathematics, right? You're discovering some deep, deep truth about the universe, okay? Like, what do you think? I mean, is mathematics something that we invent, or is it like built into the universe? Because physicists know, right? Physicists do experiments. So like, we study stuff that, we throw these atoms at each other, bang, bang, right? And we observe something. So we are discovering stuff that's around us, right? Whereas mathematicians, no, they just sit down at a desk, right? With a pencil, or walk around in a park and think, right? What are they discovering? And now they are saying, well, we have independently discovered this branch of mathematics. This guy discovered this branch. This other guy in ancient Greece, he discovered logic, right? This guy in Sweden discovered type theory, and they discovered the same thing. There is some really, really deep truth in it that we are discovering. So it's like there is some Platonic idea, right? I don't know if you've read Stevenson's novels about there's this novel in which there are multiple universes and each of them is more Platonic than the other. And people move from one to Platonic universe to another. But mathematicians think that this is really what they are doing, right? So, and I was thinking about it, and I thought, no, this is really not. There has to be a simpler explanation, okay? And that goes back to the way we do mathematics, or we discover the universe, right? So what do we do? I mean, we are like we humans, right? We are these evolved monkeys, right? Now, we have evolved our brains. So some parts of our brain evolved, since, I don't know, a billion years of evolution, like the image processing stuff, for instance, has been evolving for a very, very long time, right? So this is really, really very good system that to like analyze visual input. Right? That's been evolving for a very, very long time, starting with bacteria that would just, see whether it's bright or dark and change their metabolism, or, then they would start seeing, oh, this side is brighter than that side, and so on. And then eventually, the most important thing, where's the predator, right? Where's the food? Like distinguishing between the predator and the food, right? This is like the most important thing that makes you survive, right? And so we got very good at this. And we have inherited this stuff from lower animals. And there's been a lot of evolutionary pressure to evolve these things, right? And now we are trying to imitate this stuff with computers, and we are finding it's really, really hard. It's a really hard problem, image recognition, right? And recognizing who's your foe and who's your friend, and recognizing where the food is, right? And whether it's spoiled or not. Very important things. Computers don't do it very well, okay? So this is a very hard problem, but we've been working on it for a billion years, right? So our brains know how to do this stuff. But then there are things that evolved in the last 100,000 years or so, right? Or I don't know, how long is human evolution? 100 million years? No, that's not. Whatever it is, it's a tiny number, right? It's just like the last millisecond of evolution. That we suddenly had these brains that can actually think abstractly, right? We can count, we can communicate, right? We can organize stuff, right? And we can do math, and we can do science. And this is like a really, really fresh ability, right? And And we've been doing science for the last few thousand years or something. So that's nothing on the evolutionary
what's
scale.
cool about math
And we are doing
is that
with
it
these
feels
brains.
like
Where do these brains come from? Right?
like
They
investigating
evolved
your brain.
to do things like hunt mammoths, okay, or run away from saber-toothed tigers. Okay, they did not evolve to do programming.
This guy's
That's a
awesome.
very recent thing, right? They didn't evolve even to do mathematics or logic. No, they evolved to do stuff like hunting, like finding food, and especially organizing ourselves into groups, right? Social activities, right? So and communicating. So language, right? So we have these language skills. This is a very fresh thing, right? So compared to the complexity of our visual cortex, this newly acquired ability to actually think abstractly and using a language, that's a really very fresh thing, and it's very primitive. Okay, it hasn't had time to evolve. It's very simple, and we are using this tool that we evolved to throwing javelins or arrows, shooting arrows and communicating with other guys like, oh, here, the mammoth is over there. No, don't run there. Or right behind you is a saber-toothed tiger, or there. So we are now using this tool to do mathematics. So there are certain things that we found useful in doing abstract thinking, okay, in doing mathematics. And the major thing is we come head to head with a very complex problem, like how to provide food for our tribe, right? And we solve it. How do we solve it? We divide it into smaller problems that we can solve. And then we combine the solutions, okay? So this is the only way we know how to deal with complex situations, by decomposing these things into simpler things, and then solving them, the simplest problems, and combining the solutions into bigger solutions. And this is everywhere, okay? You find this is so permeates everything we do that we don't even notice it, okay? But this is how we work. And because this is how we work, this is how we do science as well. So every branch of science, every branch of mathematics we can only see these things that can be chopped into pieces and then put together. So no wonder they look the same, okay? Because we can only see these problems that have the structure. If they don't have the structure, we just don't see them. We just say we cannot solve this problem, okay? Let's do something else. Maybe we can get grant for solving that other problem because that seems choppable into smaller pieces. This one doesn't. Let's forget about it. Let's not even talk about it, right? So one could think, okay, so maybe the whole universe is like this. Maybe everything in this universe can be chopped into little pieces and then put together, right? Maybe that's like the property of this universe, and our brains are just reflecting this, okay? And personally, I don't think so. Maybe I'm wrong. Hopefully I'm wrong. But I'm a physicist also. I mean, I started as a physicist, right? So I saw what was happening in physics. And in physics, we also wanted to chop things into little pieces, right? And we were very successful at this. We found out that matter is built from atoms, right? So atoms are these things that we can separate and can study, right? Their properties, and then say, okay, the property of a rock or a piece of metal comes by combining the properties of these atoms. So we can decompose a piece of rock into atoms, study them, and then recompose it, right? And then we have the understanding of that, how this is. But then we didn't stop at that, because we wanted to see what's inside the atom, right? So there are these elementary particles, there are these electrons, protons, and so on. So at some level, I mean, if we want to be decomposing things into simpler things, these simpler things have to have simpler properties. For instance, what's the simplest thing that we can imagine for an elementary particle? It has to be a point, right? It should be a point. I mean, if it's a ball, right, then maybe we can cut it, chop it into smaller pieces, and then do the decomposition, recomposition, and so on. So at some level, some lowest possible level, we cannot chop it anymore, and we should find a point, right? So an elementary particle should be a point. That would be like the end of this level of decomposition, right?
It's pretty cool. It's a good idea.
And try doing this, right? And
Good
we have like
concept.
the standard model of particles in which we assume that particles are points. We sort of cheat, because it turns out that we cannot really deal theoretically with point particles because they lead to infinities, like 2-point particles when they get very close together, right? The interaction goes to infinity and everything blows up. So we came up with this renormalization theory, which is like a big hack, to get rid of infinities and so on. And of course, we're not very happy with that. So they thought, okay, so maybe at this lowest level, things are not as choppable as we thought. Maybe nature really does not follow this kind of, divide and then combine. So they came up with this idea that maybe elementary particles are strings, right? Have you heard of string theory, right? Like, what a crazy theory this is. That this most elementary thing is not a point, but it actually is a string, and you cannot chop it, right? It's like the elementary thing is not divisible, but it's not a point. And quantum theory now says, this is another non-choppable piece of knowledge that we found out. It says, okay, so if you have, a bigger system, right? Maybe you can separate it into elementary particles, and you can say, okay, I have a system of 10 particles, I know properties of these 10 particles, right? And I call this system something bigger, like an object, right? And I can find out the structure of this object by looking at these particles. And it turns out in quantum mechanics that a state that they don't add up, okay? A state that has two particles is not a sum or a product or a convolution of states of a single particle. It's a new state, which follows a different, differential equation, and so on. So we try to separate particles, and suddenly we cut the particles apart, and it turns out that, something weird happens in between when you're cutting, right? You are actually changing the system by separating things, okay? So maybe at the very bottom, or maybe there is no bottom, or maybe at the very bottom things are not separable. Maybe things are not composable. Maybe this composability that we love so much, that is not a property of nature. That's what I'm saying. Maybe it's not a property of nature. Maybe this is just the property of our brains. Maybe our brains are such that we have to see structure everywhere. And if we can't find the structure, we just give up. So in this way, category theory is not really about mathematics or physics. Category theory is about our minds, how our brains work. So it's more of epistemology than ontology. Epistemology is how we can reason about stuff. We can have a bigger system, right? Maybe you can separate it into elementary particles. You can say, okay, I have a system of 10 particles. I know properties of these 10 particles, right? And I call this system something bigger, like an object, right? And I can find out the structure of this object by looking at these particles. And it turns out in quantum mechanics that a state that they don't add up, okay? A state that has two particles is not a sum or a product or a convolution of states of a single particle. It's a new state, which follows a different, differential equation, and so on. So we try to separate particles, and suddenly we cut the particles apart, and it turns out that, something weird happens in between when you're cutting, right? You are actually changing the system by separating things, okay? So maybe at the very bottom, or maybe there is no bottom, or maybe at the very bottom things are not separable. Maybe things are not composable. Maybe this composability that we love so much, that is not a property of nature. That's what I'm saying. Maybe it's not a property of nature. Maybe this is just the property of our brains. Maybe our brains are such that we have to see structure everywhere. And if we can't find the structure, we just give up. So in this way, category theory is not really about mathematics or physics. Category theory is about our minds, how our brains work. So it's more of epistemology than ontology. Epistemology is how we can reason about stuff, how we can learn about stuff.
No kidding. What a killer quote.
We cannot learn what things are, but we can learn about
that's
how
so beautiful.
And that's what category theory tells us. Okay, let's take a break.
Holy shit. All right, we got that. I want to see the transcript on that. Oh wait, it went forward.
It's really
and suddenly we cut the particles apart, and it turns out that something weird happens when you're cutting. You're actually changing the system by separating things. So maybe at the very bottom, maybe there is no bottom. Maybe at the very bottom, things are not separable. Maybe they're not composable. Maybe it's not a part of nature. So it's just the way that our brains work. So literally it's like we're studying how our brains work through concepts like this. Whoa. So like we're making ML models. I guess ML models have been following like a similar path when you look at them on Hugging Face, where there are a lot of them on here. And the way that they all kind of work is that someone has trained a model. So this is going to be like a fundamental model that people are now going to extend. So effectively what it becomes is like composable things and models built on models. We train data over there. We graph that. Kind of like the training is like kind of grafting things together, where it's like you have an original model, you have this other data set, and then you kind of like let that other model kind of like connect with the data. It's very interesting. But anyway, as this relates to like why this quote is like so interesting to me is that like we do things like simplify math down to like a point, like he said in this video. And so what happens when you like cut that point in half? Like or maybe there is something beyond a point. I don't know. It's just interesting thinking that all of this stuff is based off of the way that our brains work and how we see the world, because there's so many other things in this world that we can't see. It's like we are just absorbing like electromagnetic radiation, and so like I'm looking at a plant and that's green, like that's my best guess. Like it's and green is just a word that we use to describe like that thing that we see. So wow, that's really interesting. That's cool. All right, let's start the next one. What is a category?
So that was the philosophical part of my talk, and I will be slowly moving towards really more practical. I mean, practical in the sense of mathematical stuff, not so much philosophy. Okay. But from all this talk about how our brains work, the important part is that we want to be able to. The major tools in our arsenal, right, are abstraction, composition. And I'm going to add one more thing to this.
I wonder how well OCR would work on this, because he's like writing
so,
text.
as I said, abstraction means we want to get rid of the details. We want to like forget about the assembly language of or machine language of what we are doing. And that's not only in programming, it's also in mathematics or in physics. We want to get rid of unnecessary details. Okay? So once we get rid of unnecessary details, then suddenly what happens is that things that were different, but they were different because of unnecessary details, they suddenly become identical. Right? Like if you have, let's say, 2 billiard balls of the same color, right? They are not really identical if you look under the microscope. They have different maybe scratches, maybe they have different configuration of atoms, right? But you can replace one with another when you're playing billiards, right? So once you abstract, things that used to be different now become identical. This is why we have this notion of identity. And this notion of identity, because of abstraction, is always non-trivial. Okay, so there are things that are strictly identical, so like you can replace one with another and you won't notice any difference. But then there are things that are identical for all intents and purposes. Okay, and in mathematics, this is like a very, very important thing. That there is this distinction between it's really the same, or it's not really the same, but people look at it as if it were the same. Okay, and there's even a whole foundation theory that's being now developed that's based on like distinguishing between what's identical, what's not identical. It's called homotopy type theory. It's a very hot topic right now in mathematics. That just tries to solve this one problem. What are things that are equal, and what are things that are almost equal, or as they say, isomorphic, right? Is isomorphism and equality the same thing or not? Should we treat it the same way or not? And so on. So, composition and identity, these two things, they just define category theory. This is all there is in category theory, okay? It just encompasses composition and identity. So, you are now ready for the first definition of category, okay? And I wish I could define category what a category is very precisely, but I can't. Okay, so I will be using terms like a bunch. Okay, a category is a bunch of objects. Okay, and like you would want me to say it's a set of objects, right? Because a set has a precise mathematical meaning, right? But it's not. Okay, so you have categories that have sets of objects, and it's fine. But not all categories have sets of objects. It turns out that there are things that are bigger than sets. Okay, and you might think like, what can be bigger than a set? I mean, what's a set? A set is something that that has a bunch of elements, right? Like a set is defined by membership. Is this element a member of the set or not? But then, it's like, but you can build sets with sets. And you can say, I have a set of sets that are 2-element sets, right? And I have a set of all sets that are of this particular shape, right? So elements of a set can also be sets, right? It's like, from a set theorist point of view, everything is a set, right? They have the set hammer, and everything is a set nail for them, right? So sets are built from sets and so on. And then you can say, so how do I define a set? Okay, I will specify what kind of elements it has, right? So I can say, okay, I have a set of sets. Like there are some sets that are members of themselves, and there are sets that are not. Like a set of dogs is not a dog. So that's one. But a set of, what's a good example of a set that is a member of itself? Yeah?
A set that contains only itself.
A set that contains only itself. Okay. Yeah. So now if you can define a set that, so you can also define a set that's a set of sets that are not members of itself, right? And then you can ask, is this set a member of itself or not? Right? And if it is a member of itself, then it should not belong to the set. And if it's not, it should belong. It's like with the, Barber's paradox. If he shaves himself, then he should not shave himself. If he doesn't shave himself. So you get into these paradoxes in set theory, right? So if I say, okay, a category is a set of objects, then I immediately get into this problem. And in particular, you cannot define a set of all sets. for some other reason, right? Because it's too big, it's like a power set of, it would have to contain all its subsets as well. So the set contains all sets, including its subsets and so on. So these are the mind-blowing things that set theories are thinking about, and they cannot sleep at night. So a category says, the category theories say, let's not worry about it, right? Well, they do worry about it, but they have ways of doing this, right? So I will say it's a bunch of objects, okay? So a category consists of objects without specifying further whether they form a set or a bunch or a class. Sometimes it's called a class, which is like less precise than a set. And these objects I will just draw as dots, you know, and arrows. And these arrows are called also morphisms. I'll be sometimes saying morphisms, sometimes I'll be saying arrows. So a morphism or an arrow is something that goes between two objects. So you have an object A, and you have an object B, and you have an arrow between them, and you call it F, okay? And now you might want to ask, you know, but what's an object, right? And I can't tell you, okay? An object is a primitive in this theory. It has no properties. It has no structure, internal structure. It's nothing. It's like the atom. It's a point. It has no properties, okay? What's a morphism? Well, a morphism is also a primitive. It has no properties. Well, except that every arrow has a beginning and end. Okay, so that's a important thing. So in fact, the reason for having objects is so that you can mark the ends of arrows. Okay, they don't serve any other purpose as just being names for the ends of arrows, or identifying the ends of arrows. Okay, and notice that this is like this is really funny that we are using arrows here. It's like going back to this what I talked about the primitive human beings hunting mammoths with so right? Well, they do worry about it, but they consist of objects.
Category objects.
Without specifying further whether they form a set or a bunch or a class. Sometimes it's called a class, which is like less precise than a set. And these objects I will just draw as dots. You know?
What's cool is like you can detect like changes on
arrows,
the whiteboard.
And these arrows are called also morphisms.
And
I'll be sometimes saying
then,
morphisms, sometimes I'll be saying arrows.
Start the transcript, so it's
So
like
a morphism or an
like
arrow
once
is
he's
something
done
that goes between
writing,
two objects. So you have an object
so
A,
you have to classify like
and you have an object B,
him
and
writing
you have an arrow between
something,
them, and you call it
and then
F,
when he's
okay?
done, then everything that he's
And now you
saying
might want to ask,
can now be
you know,
like
but what's an
put
object?
directly under it.
Right? And I can't tell you, okay? An object is a primitive in this theory. It has no properties. It has no structure, internal structure. It's nothing. It's like the atom. It's a point.
So a category
it has no properties.
is an atom.
Okay. What's a morphism? Well, a morphism is also a primitive. It has no properties. Well, except that every arrow has a beginning and end. Okay. So that's an important thing. So in fact, the reason for having objects is so that you can mark the ends of arrows. Okay. They don't serve any other purpose as just being names for the ends of arrows,
Abstraction.
or identifying the ends of arrows. Okay.
Position.
And notice that
T.
this is like this is really funny that we are using arrows here.
Category.
It's like going back to this what I talked about the primitive human beings hunting.
Can I just take a fucking
mammoths
screenshot?
with bows and arrows, right? This is really a very interesting thing
Come
that
on.
we perceive the universe through these notions that were developed by hunter-gatherers, right? They had they described the world in terms of spatial relationships, right? For instance, so they like when I'm talking about category theory, when mathematicians talk about it, they will put things in space, maybe with their hands,
that's so
manipulate. So we know
sick.
how to manipulate things, right? We know how to position things in
and I
space.
get
We
the,
talk about spatial relationships. Something is above, something is below. Higher level of abstraction, lower level of abstraction. These are all spatial
shit.
relationships, right?
Yeah,
Now,
I get the
hunter-gatherers
link to
also
this
understand
video.
movement. It comes from here, goes here. This is movement. This is from arrow, from A to B. Right? It has this little thing here with barbs, right? So when you hit the animal, it can't just pull it because it's okay. So, and of course we have social language. We hunter-gatherers we're social animals. So they talk about relationships between things in terms of this guy.
Wait. Oh, I think if you play it through here, then whoops. You can't do like screenshot. Oh man, I love screenshot. No, what is it? Timestamp? That's so cool. So you can like watch it. And then add timestamp. That's like cool. Oh, that's pretty sick. Oh, damn, dude. I wish logsex interface like whole thing didn't suck. Cuz that's such a great feature. That's so nice. Can I do like data log? Can you like data log Golang? Why is that page not found? No. Dude, link rot sucks. Oh. Yeah, what do you got? What do you got for me? What do you got for me? Archive.
Points at this guy, and by movement, going from this place to that place, through this place, and so on. So we'll be using this language all the time, and I want you to like realize what kind of language we are using and how it actually constrains us. Okay. But anyway, so we have objects, and objects we draw in some kind of spatial relationship usually, because we are using the spatial part of our brain. We have morphisms, which are arrows, so they suggest some kind of movement and relationship between people. So, what kind of things can happen? I mean, we can have, let's say, multiple arrows going between objects. So if you have object A and B, you can have 0 or more arrows going between them. So every time you define a category, you specify, what are the objects of this category, and for each pair of objects, right, you specify the arrows that go between these objects. Some objects are not connected with arrows. Other objects are connected with one arrow. Other objects are connected with infinitely many arrows. Could be uncountable number of arrows going between two objects. Okay. So like if you have an idea that the category is
that's just wrong. This is. Man, dude, Google's is not doing a good job. No. And then this interface, I don't want to do that. I don't want to. Feedback is so important with AI. And if you make it like annoying like this, like, it's just not going to be helpful. I wonder what ChatGPT has for me. On a pure data log implementation in Golang, use a library if you know one. Golog, does that actually work? Golog? Gotlog? Any forks? Oh, sick. Okay, this guy's maintained it. Interesting. Well, I start it. Save it under Golang libraries. Enter ideas. Use data flow. I don't know. Okay, whatever. I'm gonna get back to watching this. Theoretically, this works. And then there's like just enough steps with this. Like this is pretty straightforward, but there's just enough steps that I wish that I could just click a button and it's all like done for me. Path to image. Online coding escape room. That's an interesting idea. What? The hell is that? No, I want like the GitHub one, not like some weird game.
To create a profile for your escape room. You can under solution, as well as assign hints to each part in which parts of the escape room they will be shown. You can customize this interface by choosing one of the 21 themes available.
What the fuck is this?
You can also add gamification elements such as a countdown, a real-time leaderboard, and you can set up the class interface escape room. The escape room is set up. When students sign up, students will watch the text box in the top bar. If it's correct, they will see how their progress increases, and they will be shown the information relative to the next puzzle. Developed as external. During the escape room, teachers can monitor students' progress.
Damn. Luke did such a great job with this site. This looks so sick. We gotta... Oh, shit, dude. Oh, Luke, you motherfucker. Damn, dude. He's definitely good. He's right. There he is. There's Luke. Oh, man. Killer. I'm so happy. XCTF, baby. Oh no, I don't have. Damn it! I need to submit a request to get XCTF. This is gonna be huge. Okay.
I'm so bad with names.
Yo, what's up?
Hi. Somewhere else just joined.
Who's Brad Chris?
Brad Chris is a friend of mine.
Oh hey, what's up?
What's up?
He just wants to watch.
Okay. You can participate if you want, Brad Chris.
I can participate. Oh yeah, sorry. I was just explaining to him that I have a CTF that I run every year for high schoolers. Oh. And I've built so I can put the link in the chat here. I built like this open source CTF platform that people can use to build CTFs in the style that I run them. Yeah, it just it doesn't quite feel right at the moment. Like I'm trying to like make it so it build. But anyway, the coding escape room that sounded really cool.
Mm-hmm.
That's such a cool idea. How have you guys done it? Are you guys working on it?
We're doing one right now. Let me share my screen. But they have like 10 different ones of varying lengths and difficulties and stuff. So, but you're given like a scenario and like different things you can click on. But then also there's like a coding window where, like right now we each have our own coding tab, but you know we can make more if we want to. But every tab is collaborative. You know, we can all type on the same one, and you know we can also watch and see what someone else is doing. And then if we want, we can change the language to. They have just about every major language that you could want, but we're just doing Python. So.
Oh, interesting.
Mm-hmm. So right now, there's 2 puzzles we're working on. This one, so for this one, it's a chess piece, and right now it's at F4, and
oh, there's multiple. There's multiple that you're working on.
Mm-hmm. Yeah, there's like 5 or 6 different puzzles, and as you unlock,
oh my god. That's sick.
You can get a different puzzle and stuff. Yeah.
That's freaking sick. I love that idea.
Hang on, let me show you this too.
Holy shit.
So these are all the different escape rooms they have. And
so,
if you look at the bottom, it tells you like the different difficulty and like how long it takes.
So you could make it so that the escape room is just like a shader. Like people can write shader like art, and then like every room that you're in, like you get to like be like in that environment. That would be sick. Wow, this is really cool. Thanks for showing me. This is amazing.
What do you mean by shaders?
By shaders?
Yeah, what do you mean by shaders?
Oh, so like let's see. What's it called? Shader Toy? Do you know what Shader Toy is?
Nope.
What's the site? Shader Toy. Shader Toy beta. Yeah. Oh yeah. So your GPU, your computer's going to take off if you load this site. But it so everything on here, it's like it's kind of like the it's like CodePen. Do you know CodePen?
Yeah, I do.
It's like CodePen, but for like these, like this really powerful technology that your browser has called like OpenGL shaders or something like that. And this, you can write code to make really crazy graphics things because they're just kind of like, they're all just kind of mathematical functions. And so if you are familiar with like that type of stuff, you can make really, really cool stuff. Or I guess I could also just show my screen.
Yeah, you can.
Bow.
I think I finished the decoder, but the weird part is it wanted the message as a list, not a string. So I made it into a list, then I returned it.
Mm-hmm. Yeah.
Nothing happened.
You could use ChatGPT to generate these problems too.
Yeah, that's what I was thinking.
Holy shit, dude. Oh man, this is sick. This is so cool. Yeah, I've been running this competition for like the past 7 years.
Wow.
And it's
Are
like
you like a senior security analyst or something?
What's that?
Are you a security analyst or a senior security
I
analyst?
used to be a I used to be a security engineer at Uber. So I learned how to like write production grade like code, and now I've been like just doing that for this this thing. I went to NYU for school, and they had like a program called Seesaw, where like every yeah, oh, you know about so I used to run that, and so this has kind of like this idea has started since then. So I'm trying to make it happen.
Oh wow.
But this would be a really cool element to the competition site, to be able to like build challenges like this.
Yeah. I know like NYU is the top school for cybersecurity, so it's Carnegie Mellon. So.
Yeah, there's actually a really funny thing, because they completely threw away the golden goose that they had. I wrote a blog post about it called "NYU Dropped the Ball." Oh, I was so pissed, dude. I was so pissed. And then I also wrote this blog post called "I Hacked My School and You Should Too."
Oh. Like legally or illegally?
Definitely illegally. Like definitely could have gotten like suspended or expelled. But I did a write up back in high school, like when I did it, because I knew that I would want to have it documented, so that when I was old enough to be able to like talk about it, like it wouldn't have like busted us.
Oh yeah.
Yeah. So yeah, I don't know.
Yeah, me and my friends used to just take down the network all the time.
You used to take down the network?
Yeah. And then I went over to our this new mall that we had. And then I was telling my friend, let's go over there and take down their network. And then my friend was like, okay, let's do it. And then we went over there, and I said, you have to be on this computer, and I'll be on this computer. And then we had to do it at the same time. Like, and then we had to do the commands at the same time. And then the whole network went down. And I told him, you gotta run. Because the cameras were on.
Wow.
Because we were the only two people on computers.
That's awesome. I love high school stuff like that. It's so much fun. I think there's a router that we plugged into the school's network that once it was plugged in, we didn't even meant to do anything, but it's just like, we had a router and we're like, let's play with it. So because of how bad like DHCP is, I guess if it's not set up properly, a router can just announce itself as a DHCP server, where then all of your computers on your network start like getting IPs assigned from it versus the other network or the other router that's on there that's supposed to be telling everything about the IPs. So like our one router took down like the whole school's like internet like pretty much instantly, and we had no idea what we did, and so the IT person had to walk around from room to room to like check all of the networking setup, and I guess they found the router. I was pretty impressed that they like figured that out, that was like
well,
something they
I'm
found.
surprised that they took so long, because you're supposed to identify every port and write them down, so when it does happen, you know which port it comes from.
Yeah.
Because I don't know, it came from my CCNA training.
Yeah.
we actually can identify which port it belongs to, and that's why every port has a number on it. Typically, if you're setting it up properly, that's why when the drops happen, you have a number on the box, so you know which box you're supposed to go to. Otherwise, you're hunting for it. Like imagine a large organization not labeling anything, and it could be one of 1,000 ports in the world.
Mm-hmm.
You're like trying to find out which one it is. That'd be impossible.
Yeah.
But I thought something I did in college was we did email tag, where
email tag.
Yeah. So in the header, it tells you the IP address of the computer system that you are on.
Mm-hmm.
So each lab has an IP address associated with each computer system. And then my job was to get an email from a friend and figure out which computer they're sitting on and tap them on the shoulder.
Whoa, really?
Yeah. So that's what I was doing to people. I was tapping them on the shoulder once I figured out which lab, and then I tapped them on the shoulder, and then they would go to another lab and then hide somewhere and then email me. And then I would read the email and then go tap them on the shoulder.
That's hilarious. Wow. That's pretty funny.
But what was even funnier is we would print a document and figure out which printer it printed on. It could be anywhere in the entire university.
So you went to every printer?
You have to figure it out, but then what we do?
I mean, how do you figure out? You have to physically go to each printer?
No, because each printer is assigned.
Mm-hmm.
So you have to figure out which are computer system IP addresses and which ones are printer IP addresses.
Mm.
And then once you isolated the printer IP addresses, then when your friend gives you an IP address that they printed on, because you can actually print onto a computer too, by accident, but because it creates a file when you do that. So they would send me an IP address that they printed on, and I have to figure out which printer it is before we get in big trouble. Because they usually print out someone's email address on there.
Wow.
And then some of my friends would hide their email address, like pretend to be another friend. That's how we got into the whole header thing, was because a mutual friend of me and my friend would send an email out with one of our email addresses on there, and then the return addresses to him. So he would send it out pretending to be one of us, and then try to get us angry, and then we would have to look at the header to figure out, was it actually our friend that sent it out or somebody else?
Very cool.
I don't know what's going on. Why is it not working? Provide solution does not match the expected format.
Yeah.
Oh, because you put it as a string as a return. It has to be a list.
Oh, it has to be a list? I thought it had to be a string. My bad.
Oh. I think because that's why they had that other part to it. I think you deleted that part. And then that's where it ended. And I think it has something to do with the module typing. That's why it says from typing import list.
Mm-hmm.
I don't know what that. I probably should do a manual on that. I don't know if it has to be a list or not. But it errored on me until I made it into a list.
Gotcha.
But I don't know if there's a way to reset the whole thing, because there was that list part after message string. maybe I should move on to something else since you're working on that one.
Yeah. It says there's 26. 20. Or I mean, I unlocked the hint on it. And it says there's 26 of the letter thing. So I mean, I'm assuming there's a conversion for every letter. So I'm trying to put them in alphabetical order right now. So, but
it might be easier if you took the list and put it into Jupyter Notebook and then sorted it.
Mm-hmm.
Because otherwise, you're I don't know how long you're gonna take to.
Yeah, I can't find E though, but.
I don't think we have E yet.
Yeah, Y to M. YZ.
You don't have E?
Yeah, I'm looking for E because like
IG.
Right, that's IG, LB. What is that one? Is that an F?
F to Q.
Is there a shift, or is there like maybe a certain pattern to the way that they've shuffled the letters? That
I think this is Caesar cipher. So they're just picking letters associated with them.
Is it consistent difference?
I mean, yeah, I mean, I don't think so because a Caesar shift would be a consistent difference, but I don't think this is.
Yeah, so this is A to X, B to I.
Oh yeah.
But I don't know what the other name for it was.
Substitution cipher.
Yeah.
Yeah, if it's substitution, you would need to know. What are there any characters that are missing in that decoder from the ciphertext? Like if you looked at...
They're all over the place, so we're missing quite a bit.
I don't think so. We can look. Oh shoot.
Can't you just print out the
the
original message?
You would have to use it in Jupyter Notebook because it doesn't do it on the screen here.
All right.
Or
that's the original message right there.
Yeah. So what's missing? What's missing from the decoder that is a character in there?
Yeah. There's no E's in it, so we don't even need to find E. But
like, if there's no character that's missing, then
oh, that's what you meant.
Standard error. What the fuck does that mean?
I don't know.
Oh my god. They just give you the most cryptic errors?
Yeah.
Why? Why don't they give you the full error?
I think it's the STD output.
Also, this sucks. Like, having a proper IDE would be so much better for this.
Oh yeah, for sure.
Wait, why don't you just do it in like VS Code?
I mean, that's true, I guess.
Yeah.
But
just pop that in there. That sucks. Or you can use GitHub has code spaces. Have you seen that?
Nope.
If you go to github.com and press like a dot, like a period on your keyboard on any repo, you can like pop open like an editor.
G to N. Oh, we're trying to put in order.
It says there's an error in line 36. What the heck?
Well, that's because it's another set of code.
Oh my god. Oh, you got to close parenthesis on 31.
Yeah. Yep. Look at that.
That's standard. That's miserable. Who the fuck wrote that?
Who knows?
Standard error. Sorry, your code didn't work. We won't tell you why.
Maybe we have to have an output. Yeah, there we go. We have to have an output connected. That's.
Oh my god, why? What the fuck is that? Jesus. The provided solution doesn't match the expected format. Wait, why are you joining the string or converting the string message to a list and then joining everything back again?
So I mean, I looked up how to turn a list into a string, and that's what it said. Just use the join method. But
yeah, but it's originally a string.
Gotcha.
Yeah, the reason why there was a list that I made it into list, which I think you might have deleted. Okay, you put that back because it was actually a list string.
Why don't you can't you print to see what message is after you replace everything?
I don't think so, but I mean, it gives it to us right here at the bottom. So.
Oh, proposed solution. I see. Oh, okay.
Mm-hmm.
Yeah, that don't look right.
Yeah.
So, so we didn't put all the letters in yet. So G to N is not in there either.
Yeah, go for it. Add it.
Wait, the decoder needs to be swapped around. So X needs to be the key, A is the value. Because it's saying from G to N, and so what you're seeing in the ciphertext is N, and now you need to go back to G. Yeah, so everything...
Well, the way
yeah, I think you're right, because there's no A's in this at all.
Yeah. Yeah.
Oh my gosh. Okay.
There's A's in the violin.
So for this, we have it all backwards. So we have to take what's on the left and move it to the right.
Just put that in ChatGPT. Ask ChatGPT to do it.
Just
ask it. Do it.
Or in the decoder thing, just switch it there.
Yeah. You think it's the other way around?
Yeah. Let's try the other way around. Mm-hmm.
We code, right? Oh, you don't have to change everything.
Oh, there you go. Yeah, you got it. Oh, wait, no. You still have to do it because you need to be... Oh, wait, what the hell?
So what I do is I take the keys and then replace it with...
Yeah, but you need the value too.
What do you mean? I'm replacing it.
Yeah, but decoder at DEC... So decoder at DEC is going to be A on the first, or you're going to be...
So A would be the DEC?
But A doesn't exist in the ciphertext. So that lookup's always going to fail. But what you really want is to look up X in that ciphertext.
Mm-hmm.
Which ciphertext are you talking about?
It's the one in the message. Let me put it in the chat really quick so it's just easier to reference.
You mean the one that starts with DWTK, right?
Yeah.
Yep, that's it.
Okay.
Just keep in mind, there's other text that we have to decode it for.
I think the decoder is only for the typewriter message.
Can someone copy that code that you have, that Python code, into the chat too?
Yeah, hang on. There you go. My coding skills are so rusty. It's been a hot minute since I've touched Python, but
I hate Python passionately. Oh, God.
We can operate in a different language, but
no, it's fine. It's fine. I don't mind. It has an important place in the world. It's caused me so much disdain.
Oh yeah, it's quick and dirty, but at the same time, it's frustrating to work with sometimes. But...
Go is an absolutely amazing language. Like there's so much of the world that we run now is like built with Go. Go and Rust. Rust is also a good language, but it's a little more complicated to learn.
Gotcha. The only language that I despise so far has been Ruby. Ruby sucks.
Ruby? Yeah, I cannot believe people were so in love with Ruby. It was so strange.
Like they try to make it easier for people, but at the same time, I feel like for actual programmers, it's just a big headache.
Yeah.
To me, Ruby's a pain. I had to do like a small project with it in school. I was like, never again will I touch this language.
Yeah, it's pretty bad.
I got the message, you guys.
Oh, you did?
Sick.
Yeah. Do you want me to paste in the chat?
Go for it.
What can Brown do for you? United Parcel Service, what can Brown do for you?
What?
I mean, that's...
Wait, which chat did you put it in?
Oh, I guess that's the answer.
Discord chat.
Discord? Which chat room? Or which channel?
Okay, so you need to put your output into the chessboard and not the chessboard, the typewriter. And we can run it again. Oh.
Did you solve it?
No, your code's not working, but we can switch it over to manual mode. Or here,
I'll give you my code, okay? Okay, hold on.
I'm just gonna copy and paste it.
Yeah, put it in the chat. So.
Gotcha.
Which chat are you guys in?
The lounge chat on the upper right corner.
Lounge. Oh, I see the chat box.
Yeah.
Oh, it says the provided solution doesn't match the expected format.
Right.
What?
I was looking at that. It says the constraint, like it has to be less than 20 characters, less than or equal to 20 characters, but
The fuck does that mean?
Oh, okay. So, wait, it has to be, the whole thing has to be less than 20 characters?
Oh, what if
That's
you
what it
search for that?
says.
What if you search for that? What can Brown do? Oh, UPS? Or what can Brown do to you? That's like a company.
Yep.
The hell? Yeah,
Oh.
UPS. Isn't it just UPS? No, it's not the United States Post. That's the USPS.
Oh yeah. Is it just United Postal?
The fuck is
Yeah,
their name?
UPS
United
is
United Parcel
Parcel.
Service.
No.
No? This sucks. What the hell is this?
I don't think that's part of the...
Oh, it
I don't
doesn't.
know if that's part of
I
the-
got it. It doesn't like the spaces.
Oh, you're typing it.
Hey, yeah. Let's Mimi join us.
Or somebody else joined.
Yeah, Mimi join us.
Let me see if I can get it without the spaces.
Okay. Can you just like write the function and print it right there and then submit it? Print the right answer there and submit it instead of like using the whole code.
Yeah, you can.
I can. Okay.
The hell is this? Oh God. This is,
Gosh darn it.
yeah, that's really frustrating.
It's like everything's going back to that.
Yeah.
Oh, okay.
If you want, y'all can keep working on that. I'll try out the chess puzzle.
Oh, you put the codes back the way it was.
I haven't touched your code
Oh no, on the
in a
top
while,
there.
but
This screen. That's why I want to know what typing does.
Okay.
Hey, just wondering, is it too late for someone to join?
I don't think so. Give me just a second. I'll see if I can invite more people.
Okay.
Oh, yeah, we could send you a link.
Yeah, Chasing Lobsters is Mimi's friend from LA.
I'll put the
I just put
the
link.
link in the chat. Oh, you did.
Okay.
In the general chat. Yep.
Oh, thank you. Okay. Yeah, because he's actually gonna join because I'm doing finals at the moment, so I can't join, but I'll totally join next time.
Oh yeah, no worries. You're good.
Okay, well, have fun. Good luck, guys.
Thanks, Mimi.
Mm-hmm.
Hey, Chasing Lobsters.
How did you guys start playing these games?
So, I mean, this is actually the very first time we've ever done one of these together. So.
Oh yeah.
That's kind of why it's going so rough. But a friend showed me this site like 2 or 3 weeks ago, and then I discovered it's got escape rooms on here. I'm like, holy cow, I've got to do one. So,
yeah, that's pretty sick.
if we can get it working.
Yeah, this is just a really poor experience. I would completely change how I would build this.
Yeah.
Like, it makes no sense to restrict you to typing into that box like that. Like, the output should just be like the right answer or not.
Right. I mean, it is kind of nice how you can just change the languages and it's all collaborative. You know, you can be typing on the same tab together.
Also, they need a ChatGPT integration by now. Like, a competition site that doesn't make use of that is like, it's just not good. Because it's just like we invented a calculator that lets us like talk and then like reasoning stuff comes out of it. So like, why would you deprive a kid of a calculator like to like do the things that they're interested in? It just doesn't make sense. But anyway, that's my soapbox.
Well, they used to ban calculators because you could actually talk to each other through the calculator.
Oh yeah. We totally had all of that. We totally had it all. We had like fork bombs for the calculator that like we would send to someone. Because like we found like on the TA-83s like a sequence that would like hard brick the calculator. And so we would give that to people saying that they were the answers to like the chemistry test or something like that. And so when they opened that program on their thing, it would cause their calculator to crash. I don't think it was a hard brick. It was definitely like some brick that like caused inconvenience though. It was so good.
I only programmed all the calculus, like answer, like how to answer all the calculus questions.
Yeah. Store that in the programs.
Yeah, because people are taking to the AP exam.
Mm-hmm.
And then you just run the program and it gives you the answer.
Awesome.
It was really sad when my friend put his TI-82 calculator in his pocket and it got too hot, so he erased everything. So
got too hot? Was the battery about to pop?
I don't even know what happened. He said it got too hot and it reset.
Holy
so
shit.
When he got in there, none of his programs were there. I was like, I just laughed at him.
Yeah, that sucks.
Well, you gotta be better prepared.
All right, y'all. I'm gonna hop off, but this is really cool. Do you guys think you're gonna do it regularly?
Oh yeah, for sure.
Okay, sick.
Every week or something. Yeah, so.
Okay, sick. You guys should think about streaming it. Like, I think it would be like if you guys were like comfortable with that, like just like, because this is like cool. It's like watching someone play a video game.
Yeah, I mean, I would definitely like to have my coding abilities to be significantly better before I
just use ChatGPT. Fuck it, just like throw it in chat. There's no shame in that. Why not? And then there's streams called like solving a escape room with AI. Like that's pretty sick. That's pretty sick. You could get people to watch that.
Yeah. I feel like
we're not the OGs yet.
Doesn't matter. You don't need to be an OG. You can get like a reasonable following, and like as you guys do it, you'll get better.
Right. Oh, yeah. That's true. But like the thing is, there's only like maybe 6 or 7 full rooms on there. So like in about like 2 weeks, 2 months time, we would have gone through them all. But
you can do it. Do it and stream it. Get some followers.
Okay.
All right. Anyway, I'll catch you guys later. See ya.
See you, Chris. Thanks for hopping in.
No problem.
Here it is.
That's pretty sick. All right, so WebRTC looks really interesting, and I was thinking that they would be really cool to include. I still need to do that OCR thing. Protoflow work. What? No, I want like Golang library. Boom. Put something in. What the hell was the? Oh, streaming. Oh, building a And actually, there was one that that's a cool idea, though. I like this one. And that's, we'll say, XCTF ideas, coding platform. Yeah, code escape room is the idea. And then shaders can be built to have as the visual that you can hide things in, and then you can let people play with shader properties, something like that. I don't know. Anyway, that's a cool thought. That's a nice little nugget. Store that. Oh, we were trying to do the OCR thing. Okay, so we got Finder screenshot. Screenshot. That one. Okay. Oh. There's already a text. Okay. Course generate. I know how to fix that now. Okay. What is the problem? Spring connector. Okay. Okay. Oh, gotta update it. Oh, son of a bitch. That is annoying. Oh, let's just use this library. What a sick library. Okay. Oh wait, I don't need to pass the path there because I got protoflow. Okay, and then this is just data. Load font. The fuck is this? I guess that helps it significantly. Okay. Do we have the ability to do OCR now? Let's put this back, shall we? Whoops.
These objects. Some objects are not connected with arrows. Other objects are.
Yeah, we're focusing. All right. So we can call things in Lunabrain, such as OCR. So now with, oh yes, let's go. It could look better. It could look better, but file. Show me the file. I need like drag and drop. Oh shit, drag and drop file. I don't know if you can get the file path. Can you get the file path? Oh. I don't want to upload an image though. Oh, file picker. Okay. Okay, what about file picker? Damn. Okay, that's fine. So we need to drag and drop write me a drag and drop React component. No. That gets the bytes from the image to be sent as a uint array 8. Okay, so you can fine tune question to ask here. Can you fine tune a Whisper model Can you fine tune a Whisper model? How easily can you fine tune a model? This model. Okay, interesting. So you fine tune it. Awesome. All right, well, we got to do the file path manually, I guess. It's so funny. I just find myself being so anal about the smallest of things, like in the experience of trying to use Protoflow, because it's just like, if you just sit down and write the code every time you're frustrated by something and you just make yourself faster, like that's what I'm doing. I'm just making myself faster with Protoflow. Like I want to, so a great example of doing that is, so I guess we'll do the updates of Protoflow here, I guess. So what's changed since the last thing that I talked about? So a pretty significant change here is, actually, I need some water. It's going to be a long-winded. Okay, so significant changes. It looks hideous. I still desperately need a front-end developer to make this look pretty. So Luke, I'm pointing to you. You need to help me here because it's all React. You're a fantastic React developer now, like, or at least front end. Like, you made that look nice. So figure this out. So everything has provides here, and so this was an important abstraction that I needed to make because previously, if we look at the schema here, it shouldn't be too scary. I feel like I've shown it before, but like, just in case. So can we see history? We can do history, right? Local history, show history. Oh, this is beautiful. Okay. Can I see? Oh no, it's local history. Get show history. Side by side. Pop this out. Whoops. The fuck is it? Where the fuck is it? Get show history. Okay. I don't care about that. I want this. Okay. I want the whole file, please. Do I have helpful? I want expanded. Thank you. Resource. Okay, this is where we removed. No, that's okay. So, that's actually pretty funny. So, a node used to have multiple resources that it had, and resources were something that were stored in the project. Get show history. Oh, it closes the other one. Ugh. Don't like this UX. Bad UX. Show history. Okay. So there used to be resources. Now you don't see it in the projects anymore, but in projects, there used to be a separate thing called, oh, come on. Where the hell is, project. Okay. So there used to be a graph here, but there also used to be resources, and resources were this idea that I had where nodes need to come from something, and they come from resources. I think maybe they were called something else before, but whatever. So a resource provided a node. So a really important differentiation that I made was, and then similarly nodes stored resource IDs. So, and for some reason it just didn't feel right, because by separating those two things, now you have all these other types, like in a resource also kind of had this similar like one of config, which is just, it feels annoying to manage, and you want to remove the amount of times in code that you're really needing to do that. So I think a big boost here was the fact that I just turned this all into one thing here. So we're still calling these blocks. There's this move that I made. So let's see, what is the order? So I still had resource ID, and then I added these other types. And then I quickly felt like a reorganization was needed, because it's like you start overloading this and it's like, what am I looking at? So I wanted the types to be descriptive, and they just weren't at this point. So then what I did, I added code adapter, which is pretty cool. Now you can write code on the edges. So that was a cool addition. So okay, sick. So in this one, I collapsed. So a node could be any type. So like a gRPC REST thing, and then you connect them together like API calls or something. So I then collapsed them into like categories. So now all of these different node types are now in categories, because if we go and look at those different things, so now code, it's like code.proto. So now we have proper name spacing too. I figured out how to do that. Literally all it did was putting them into folders. But anyway, so now that we have this code proto, that has a definition for a server. So a code server, it's like Protoflow would be its own code server, because you can write code in Protoflow. You can extend it to do what you want. So yeah, so it's just, that's how it's provided. And then then you have this code thing. So now I had this problem, because I had this clear distinction in the type system before, where there was a difference between like a node, and I kind of originally thought of it as a block, but it's more like a node in a graph. So a node came from a resource, but those were two different types. Now I've collapsed those types in on each other. So the question is, well, now how do you represent these things related to each other? And that's still, I mean, in the type, it doesn't really show it, but I think maybe you could put in like options. That's like connects to. Yeah, let's ask ChatGPT. Write me a protobuf that has. Oh God, it's just not very good. I think the iPhone is better at transcription. Write me a protobuf that write me a protobuf that son of a bitch, that has options. That uses options to I don't know. I just think I need to just see what that looks like, what that syntax is. Oh. Was that valid, what this thing came back? Okay, not fast enough. I felt like the language guide has done a pretty good job. If you can learn everything that you need from a technology on like a single page, like you're doing something right. You've written the right abstraction. Yeah, custom options. There we go. Extend file.options. And I want to embed the type. Wait. Can I just do this? Or, wow. Is that valid? Wow, that's pretty cool. I think I need to make that change. I don't want to make it right now. So I like this because it further reiterates that this code, it's like, that's how you establish that it's related. And now I think you can like, because if you look at this server and code, like I literally, that's what the interface looks like for that. It's like Protoflow's the server, and then this is the that's the code. And then similarly, it's like that type's embedded. So you should be able to edit that. I don't know. I don't know exactly what that looks like yet, but that's cool. That's cool. Keep that in mind. Cool syntax. Hello, chat. I don't know if you guys are still there. Sorry, I like zoned out down the rabbit hole. Chat. I need to make the chat notifications better. That's annoying. So I also, oh man, I need to write the blog post. Maybe I do that tomorrow. So I got this blog post that I'm writing about hybrid searching, because people were asking about it, and I started off with like literally this is just a ChatGPT generated thing about them, and I have thoughts on it, but I need to do my own research a little bit more before I say anything. Like, because I want to talk in here about what I want to talk about. It's a very interesting idea, and there's not much written about it, and so that's why this is challenging. Like, there's a lot written about similarity search algorithms, but also a lot's been written about like things like BM25 and like dense searching. And this is, I did some research like many years ago, so it's like I have a good idea, but I'm not quite sure how to like communicate it, which is difficult. Like I need like a visualization. Anyways, I don't want to do this right now. Looks crazy. I installed VSC like a year ago, but I never got to it. How do you learn these things? Jealous of the mustache. I love the mustache. How do I learn these things? What do you want to learn? Install VSC. What's VSC? Visual Studio Code. Is that what that is? Oh, okay. I mean, I literally, how do I learn this stuff? I just code. I just code every day, like literally from start to finish. And when I'm not doing that, I read about code. Like you just got to spend time. Like these are like, this is my whole backlog. I have all these backlogs of things to read. So many. One day. This is also kind of my motivation for the thing that I'm writing, is I have all these little ideas of like how to improve this interface. Like I want to make like a Tinder like interface where I can like swipe on articles to read. Or like a YouTube Shorts. I need to make like a YouTube Shorts for my backlog. But it just takes time. It takes so much time to do that, and so I'm trying to write as, I guess that's like, Protoflow is like it is a language to try to describe in as generally as possible how to write like a web application, because there's so many patterns that people do, and it's just so annoying to watch people do the same things over and over and reinvent the wheel over and over, that it's just like, please, for the love of God, like, can we just like be civil about how we do web application development? Anyway, it's so annoying. So that's what I'm trying to build to with Protoflow, is like capture the experience of making a web app. And at its core, it's like a gRPC server is going to get you so far. And like this form, this form for like when I click on these notes, this is all auto generated. So I now have like UI components for like running code. Like they look like ass, and I'm still, please, desperately, I need someone to help with the front end stuff. But and so this one's offline if it's like translucent. Oh, right. This all kind of started because I was talking about the things that I've done. Damn, we're so down the rabbit hole. Holy shit. Okay, so I collapsed that type. We thought about the optional thing. That's cool. Was there anything more to the story? Okay, so now that all the nodes are now just nodes, that means that relationships can be more easily expressed between them. And for example, if we go and look at the implementation of these, that's in graph and then node. So I was really happy with this. So all the folders here match up with all the type folders. So there's like almost a one-to-one mapping. I was tempted, and I think I can make it work, where maybe not, put code.proto right next to where its implementation is. Maybe, I don't know. I think you can be able to mix it, but that's also kind of like a faux pas. Like you don't mess with the gods, and whoever the gods that were Protobuf, they had a very specific way of doing it. So I tread on light waters when I try to go against the status quo of like how we code. So anyway, so so this is a base node. This is like the most like atomic type of a node. It's like, what do you have? You have a name and you have an identifier. Identifier is just unfortunately needed. It would be nice if you didn't, but you need it. Maybe you can derive them somehow. I don't know. Shouldn't you be able to? I don't know. No, because they're unique instances of nodes. Yeah, every time you drag a node, it's like that's a unique instance. But could you could namespace it. Oh boy. Oh man. Okay, I think that's another really good idea. Figure out a way to make nodes a node ID a derived value, kind of like a URL. Why can't a node be a URL? Why can't it be a URL? You could totally make it a URL. So it's like, yeah. So you have like Protoflow, as like the schema. Protoflow : what would that look like? Protoflow : / and then your project name, and then project name would then you would follow with just node name. Is that it? And then like a base node could also have instead of name, you could make it be like a description or UI, user friendly name. No, it'd be description. No. You could have that as well as description. So you could describe what the code does. So the idea is that if you're using AI, if you are using ChatGPT to start your code, the description that you enter is then passed to ChatGPT and then you have the default implementation. No, this would be the GitHub. This is the GitHub URL. Or it's a git URL. And then the default one would be github.com flow labs protoflow. And then it's just the go path. It's just the go path to where your nodes are. Yeah. Package node. Node dot new. So that's the and then query parameters maybe. Yeah. Yeah. Holy shit. Wow. I think you could do that. Holy shit. Yeah. You can convert that's just the ID or maybe just have what am I doing? It's really hard to describe what I'm doing. To the best of my ability, how can I can explain it is that I am building as generalized as possible a like web application framework. So there's things that I just find myself as a developer doing like over and over again. And so I'm just like abstracting those away. And so for example, like every software project for me now, like if I'm writing a backend, it starts with like a gRPC server. So even though it's like really hard to see here, this thing is a gRPC server. Oh, of course, that doesn't even edit. Okay, there you go. Oh God, this UI type server. So there you go. So this node is a gRPC node. Yes, obviously. But that is a server that I have code running from. And that server is being run over here. And so the code for that can be found in like that thing. So, but all I had to do is like, I just was able to drag and drop a block here, and now I can do operations off of that. So for example, a gRPC server provides a gRPC method. And so it has all the methods enumerated here, and then you can drag and drop those onto the screen so that you can have something happen. So gRPC server, gRPC method, and then this is a config block. And this has the Discord. This actually has secrets, but you don't see any secrets on here. But I know that there's a secret in there, so I can show everyone this screen, and there's no possibility of leaking that information. And so that is a secret that's used for the Discord API. And then, oh right, yeah, this is like a full Discord bot. This is a full Discord bot right here, and if you wanted to write code to extend it, you could. So, because this is fundamentally what you want. It's like anytime you're writing a Discord bot, you're reading the messages from somewhere, and so you can configure that, and then you probably want to write a message back out. Now, there might be different things you want to do, but like fundamentally, like that's probably what you want. And then if someone has like another thing they want to add to it, they could go to the code and actually change around what it is. So yeah. It's just taking people's code ideas and then like showing you like developer best practices, because I've seen developers write code, and I've read a lot of code, and I see these patterns. So just trying to capture that. That's all. It takes a lot of work. It's very confusing, but I'm figuring it out. So I don't think I need that. I was trying to do the goddamn OCR thing. Holy shit. Desktop. Screenshot. Give me one. Okay. 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 OCR. Boom. That's on there. Let's go. Let's go. I hope this works. Run workflow. Questionable. I don't see anything. Did it get sent? Oh, we are currently hung. Oh, I think that's done. Okay, it stopped. I should probably print that it's stopping the workflow. Where's that? That's in Workflow Manager. Does say, okay, stopping workflow. want to see the node that started it. This is fucked. I don't like this code here. I think I need to make this work. This is frustrating to have this here. Let me go in there. That connector is actually, I think, just passed down even further. Yeah. So that's in there. Where is it used? So I think what you want to do here is pass down manager is really what you wanted. And then we go up. Go up. That's actually s.manager. There we go. But then we got, then we have a problem. No, because we removed, oh yeah, we don't quite have that, do we? That's unlucky. Because if how do we clean it up? How do we clean it up? Okay, so, I guess maybe we need a cleanup function because a workflow is going to have resources. I feel like that's reasonable. So cleanup is, I think we need it here too. So I think I really need like, I need to turn this into a builder. Oh, I see. You don't need a mutex if you have a builder. It's pretty good. It's good design. I think. I don't know. So what did I need to do then? So if that's a builder, I want to say with request, because there's a request that comes in. Until I figure out what the interface looks like, we're just going to take the data. So that's like my general principle. It's like you start with simple types, you use them as much as possible everywhere so that you can understand like where it needs to be used. And then once it gets painful to pass around that type and you've seen its applications, then you can like abstract like what is this type really trying to express. So you like let that concrete type like kind of like permeate through your code. Once it starts becoming painful, because it always will get painful to use that type, then you abstract it. so that it's easier to just define whatever type that you need it to be, and not have like the concrete like struct. So la la la. I need builder, right? I was looking at the builder for the fuck. No. It's not manager, and then I need like manager. Go under new. We'll say with requests, and then with trace. So does this become a manager builder? How did I do it? Workflow builder. Build. Oh, right. You have an instance of it. Okay. Oh, okay. So it becomes the manager. It starts out with the defaults. Okay. That doesn't exist anymore. With trace. Why did I do this? I feel like I just complicated it. I don't know. So then the request doesn't get passed in. It just comes from here. Oh. I don't know. That's fine. Okay. So, what have we achieved? Manager. Oh, I see. Doesn't take a manager, that takes a manager. And then okay, let's just no, let's just add it. Why not? No, because we want to clean up function. I could just have the observable. I could wrap that type so that there's a like an IO. Why isn't this just yeah. So then okay, and then we can have a so you don't need that anymore. And then we got our yeah, we can change context. And then that's the ID. I guess we can just ignore that for now. Not really helpful. So don't need to clean up. Sick. So return IO. Get rid of that. I really need to use the connector, don't I? Don't I already do this? Can I just return the connector? Oh, this is kind of annoying. I need to put a lock with this. This is a little fucked. Just a little bit. I see. Is there really no better way of doing this? I guess it's like you just do global state, but I don't want to do that. What did I do? Oh boy. I think I'm doing it right, but this is not 100% on this. Maybe. I think I understand what I did wrong here. Manager builder is not that. Why can't manager builder just have the stuff? Yeah. Because you need to be able to lock it. Oh, wait. Oh, why don't I just do this, though? I invert this. So this becomes part of workflow managers, and then request comes in through let's see. Request comes from here. So that's that. Then that becomes a manager start. That returns. That comes from m dot. There we go. And these also become workflow manager. Okay. And then manager just calls those. I don't think that's insane. It might be. Start, stop. Workflow manager needs to be passed in here. You can literally do that. Just toss this into the provides. Provider set. Boom. Oh yeah. Oh yeah, baby. That's what I'm talking about. That's what I'm talking about. Fucking wire, dude. This shit is beautiful. Yeah, what's start and stop. So now that's that. Build. Take me to your leader. Why does it have a hard time finding those things? don't think that needs to go there. Okay, did we do it? Got some errors. Yeah, we got a little problem with that, but that's okay. That's okay. Leave it here. Rename this to something. It's kind of like trace something. That becomes workflow manager that traces workflow manager dot stop. There you go. So, is it build? Whoa. Oh, generate. Gotta generate the types so Waya knows how to pipe it up. Oh yeah, go Waya, go Waya. Okay. So what? Oh, we're trying to run the OCR. Oh, at least it saves it. Oh. Still hung. Still hung. At least you can stop it now. Oopsie. We got nothing. Do we... Oh, maybe we never connect. Maybe we never connect. Yeah, where would we have connected? Manager. Yeah, we do connect. Okay. Workflow manager. All right, let's set breakpoint. What we got? What we got? Okay. Run workflow. Step in. Go over. Yeah, we got it all. Cool. So let's get a breakpoint over here. Because that still should be the same instance. Workflows. Yeah, that's there. So why are you crying? we have, oh, we do. Request. We don't add the request. Don't add the request. With request, we don't add the request. I see. Start. Get workflow. Start it. Restart it. Request. Where's the request come from? We do that build somewhere. Oh. With requests. See dot message. So at least we should be able to see the workflows. Fuck. Come on. Oh wait, we don't have any started. Duh. Run workflow. Stop workflow. We've stopped it. Okay. So you can cancel. Sees it. So actually the problem is with the code actually running. I guess let's validate that this is being called. Doesn't look like that's being called. Output. Done executing single gRPC method. Right into the output stream. I thought I didn't have to deal with this anymore. Wire method. Okay, I guess let's see if this if we actually write to the output stream. Okay. output is nothing. Nothing. And we don't get that. What if we... Okay. That doesn't work. If we bring it up. Now it's online. Go to run. Don't see anything. Maybe I need to debug this one. Debug. Okay. Whoops. Okay. Okay, that's getting hit. Cool. Cool. Text. What do we got for text? Nothing. I see. Beautiful. So that is right. Damn. Oh, maybe there's an error. Uh-oh. Looks like we jammed something up. Interesting. It's like something's being jammed up. Anyway, that's it for